Hello friends, in this lesson we are going to learn the basic concepts of game theory. In game theory, it's very important to know some special keywords like strategy, payoff, okay, so repeated game, sequential game. So what is the example of sequential game? Chess, simultaneous game, repeated game, sequential game. So all these keywords are important, and we have some important concepts also like zero sum game. In zero sum game, let's take a plus b is equal to 0. That is to say that if a gains, then b loses, and if b gains, a loses. So a plus b is equal to 0. It is 2 sum zero sum game. Okay, 2%, not n%. Here there are only 2%. Suppose if we have 3 persons, then a plus b plus c is equal to 0. And if we have n% game, then a plus b plus c and so on up to n terms is equal to 0. So this is zero sum game. So lots of game in real world are zero sum game, especially in share market, because if a loses, then b gains, and if b gains, then a loses. Okay, so this is zero sum game, 2%, 3%, or up to n%. And it may be possible that the game should not be zero sum game. So here a plus b is not equal to 0. Okay, so there are many cases. Suppose if we have clean air, fresh water, then both a plus b or a plus b plus c or a plus b plus c up to n get benefit from fresh air, fresh water. Okay, so it is not zero sum game. Okay, zero sum game means is equal to 0, and non-zero game sum is not equal to 0. So a would get benefit, b would get benefit, c would get benefit, all would get benefit, because it is public good and it is non-excludable. Fresh air, fresh water, defense, and education, free health, so everyone will get benefit. So it is very important, and I think you can differentiate now what is the difference between zero sum game and non-zero sum game, and 2%, 3%, up to n%. Okay, so please note that these things. Then we have in game theory Nash equilibrium, so dominant strategy, mixed strategy. So let's discuss about these things. In dominant strategy, player maximize its payoff. Okay, every player is trying to maximize its payoff irrespective of another player response or reaction. So it is dominant strategy. And mixed strategy is mix, that in this case player have some mixed type of strategy, that is he or she possesses some probability of doing something for maximize its utility, or you can say for or maximize its payoff. So it is mixed, dominant. And what is a Nash equilibrium? It's very important. In Nash equilibrium, both the players are trying to maximize their payoff. Okay, so it's very important. In Nash equilibrium, both the players are trying to maximize their payoff simultaneously. So this is known as the Nash equilibrium. So these terms are extensively used in game theory analysis: sequential game, repeated game, and non-sequential game, zero sum game, non-zero sum game, 2%, n%, strategy, payoff, and dominant strategy, mixed strategy, Nash equilibrium. So I do hope that you will enjoy these terms very much. And in game theory, the analysis is very simple, but if you infer the results based on game theory, it will give you immense potential to solve the problem. And you know very well that game theory is the product of Second World War, and it's purely mathematical, and it's purely mathematical, also probabilistic in nature. We can easily find the probability of what will happen, and if probability is more than 0.5, then you can take the action. So this is the application of the game theory. So I do hope this you will enjoy this lesson very much. So keep in touch.